Hi, this is Professor Fernandez, and this is video 2 in lesson 20. We're talking here about the rules of logarithms, and I'm going to finish this example that I started in video 20.1 from Calculus Simplified. So I copied over here on the left-hand side. You'll see lots of different pieces of useful information. There are 5 of them. The first 3 up here I had talked about in this previous video, 20.1. I added 2 more down here, and when we get to needing to use them, I will review them. You'll also see on the lower part of the screen here the rules of logarithms. This is theorem B1 in Calculus Simplified. Same deal here. When we get there, I will tell you what those are and how we use them. So let's take a look at the example. It says solve each equation for x, and we're just going to do these 2. A and B, again, I solved in video 20.1, so check that out if you're interested in those solutions. Okay, so zooming in here. First one says log base 3 of 2x plus 1 equals 1. How would I solve for x here? Well, x is here in the argument of the logarithm. And to undo the logarithm, that's when I'm going to use an exponential function. So I have 2 things that I could do here. The first one is going to be based, 2 approaches. The first one is going to be based off of the stuff we talked about in the previous video, 20.1. I'm going to scroll to the left here. If I want to start with a logarithm and convert it to an exponential equation, that's exactly what this fact is for. So it says log base b of c equals x, converts to b to the x equals c. What I explained in video 20.1 is the way this works. It's kind of like a circular pattern thing. So if you start here, you can say b to the x equals c, right? B to the x equals c. So let's apply that over here. This is approach number 1 to solving this exercise. So to apply that here, I would say 3 to the first equals 2x plus 1. So 3 to the first equals 2x plus 1. And you can see that, just knowing that makes this a much simpler problem, because now I'm solving 2x plus 1 equals 3. I subtract 1 from both sides. I divide by 2, and I get x equals 1. So that was a very quick algebra problem after knowing this fact, right, and understanding how to apply it in practice. Great. What is the second way we could have done this problem? Okay, let's talk about that. So the second way we could have done this problem is, like I said earlier, 2x plus 1 is in here. It's in the argument of the logarithm. We'd like to undo the logarithm. This is certainly one way to undo the logarithm. I should say more specifically, this is one way to undo the logarithm, this fact. Another way to undo the logarithm would be to exponentiate both sides of the equation. And it works best if you use the same base, right? So here we're taking log base 3. So why don't I say 3 to the log base 3 of 2x plus 1 equals 3 to the first. So 3 to the log base 3 of 2x plus 1 equals 3 to the first. So I exponentiate both sides using a base 3 exponent. Okay, how do I handle this left-hand side? So what is b to the log base b of something, right? I'm using b here as 3. So that brings us to another fact over here. This is fact number 4. And fact number 4 actually flows directly from number 1, right? So if I go back to number 1, again, I talked about this in video 20.1. This one says b to the x equals c converts to x equals log base b of c. And then a quick little review again, same circular pattern here. X is log base b of c. So x is log base b of c. Okay, so how does this fact help for number 4? Well, notice that x equals log base b of c. So here is an x. So I'm just going to put in log base b of c in here for x. That gives me this and b raised to it. And then this equation says that that equals c. So equals c. And that's how you get this number 4. So I'm going to remove all the clutter here and talk a little bit more about that. So what does this fact say if we step back and look at it? It says that if you have an exponential base b and you raise it to the log base, same exponential, b, of some quantity c, you get back c. Okay, so you might view this another way. You might say, oh, b, let me find the right color here, b to the log base b of something equals that something. So that gets us back over here. B to the log base b of something equals something. There's a little caveat that I would want to add here, as with all of these useful pieces of information here. Everything needs to be in the right domain, right? So The exponential never produces negative numbers, for example, right? Like 2 to the x is never equal to -7. So C here can't be negative. Actually, the exponential never produces 0 either. 2 to the x can't never equal 0, right? So C still has to be positive, can't be 0. So there's all sorts of domain caveats in all of these facts, right? But I'm not concerned with that in this video. We're just learning how to solve exponential and logarithmic equations. Okay, so the takeaway here is that for our purposes, right, we can use this fact over here in our present step to simplify the left-hand side. So what does that look like? Well, 3 log base 3 undo each other, and I'm left with 2x plus 1. So that's in practice how this helps. 3 to the first is 3, so now you see that we are back to exactly the same starting point that we were doing it the first way. Okay, so I won't repeat the steps here, right? Follow these steps and you get to the same answer, which is x equals 1. Awesome. So now we've learned how to do this 2 different ways. Okay, so let's move on to the second example exercise here. So I'm going to draw a little line here, give some space. So D, log base 10. So that's another thing to remember here. Log of x is the convention here is that the base for the logarithm is 10. So I'll scroll to the left and just remind you that's one of the facts we talked about in video 20.1. So rewriting this exercise here, log base 10 of x plus log base 10 of x plus 3 equals 1. Okay, so how do we solve that? Well, so there are 2 approaches that we could take here as well. So to leave myself some more space to take each of those approaches, I'm going to delete this stuff over here and then just move over this little part here. Okay, the first approach we could take involves the use of the rules of logarithms. So I'm going to scroll down a little bit here and zoom in, rules of logarithms, right? And this is all the domain stuff. Suppose x and y are positive real numbers and r could be any real number. Then there are 3 basic rules of logarithms. There are a few more. I would call them non-basic, but there are a few more like change of base in the logarithm, for example. The rule that we're going to use here is, first of all, number 1. Why? Because number 1 says that when you have the logarithm of a product, it turns into the sum of the logarithms of each argument. So we can also use any of these rules in the opposite order, right? So if I have the sum of 2 logarithms and they have the same base, I can turn that into the logarithm of their product. So that's what I'm going to use here. So scrolling back up, I have a sum of logarithms with the same base, so I can turn that into a product. So I can say this is log base 10 of the product of the arguments of x times x plus 3. And that still equals 1. And now we're kind of back to some of those, useful facts. So I'm going to scroll to the left, right? This is log base 10 of something equals 1. I can convert that to an exponential equation, right? I'm going to scroll over here. This is fact number 2. Log base b of c equals something. Converts using that similar circular type of pattern here, b to the x equals c. So that's what's over here. Okay, so log base 10 of x times x plus 3 equals 1. I'm going to convert that to saying 10 to the first equals all of this stuff. So 10 to the first equals x times x plus 3. Great. And then at this point, we are dealing with a quadratic equation. We would like to see if it factors. That would make our life a lot easier. And indeed it does, right? It turns out that this factors into x plus 5 times x minus 2. And you can certainly check your work there. So it gives us 2 solutions, x equals -5 and x equals 2. Now at this point, you might say, okay, I'm done. I found the x values, move on. However, you got to be careful with logarithms, right? Because you have to go back to the original part of the problem to realize that x is one of the arguments of the original terms in the equation. What does that mean? Well, logarithms are, as we saw earlier, the exponents of the exponential equation, right? b to the x equals c implies x equals log base b of c. So there are lots of relationships between the domains of these functions. Like we talked about earlier, c in this equation has to be positive, right? The exponential function is never equal to 0. It's never equal to a negative number. It's always a positive number. So c has to be positive. So whatever we end up taking the logarithm of, no matter the base, has to be a positive number. So aha, that's a problem in this in one of these down here. Because if x is -5, if we claim that that's one of the solutions, well, then x would go over here, and we would be taking the log base 10 of -5. Can't do that, right? C has to be positive. The logarithm, the argument of the logarithm has to be positive. Okay, so what does that mean? That means that we have to reject this as a viable solution, x equals -5. Okay, how about 2? Is 2 a solution? Well, we would run through the same check. So going up here and doing the same type of check, if we put a 2 in there, nothing goes wrong, right? 2 is positive, that's great. What about if we put a 2 in there? I get 2 plus 3, that's 5. Log base 10 of 5, that's okay, no problem. So 2 is a viable solution, and it is the only solution for this problem, not 2 and -5, because of what we just talked about. Okay, I'm tempted to say this, and I will, you can always use a calculator to verify whether or not these are solutions. For example, if you try to use a calculator to put in -5, you would be calculating log of -5. And right then and there, the calculator would give you an error. It would say, I'm sorry, this is just not possible, right? So that would be a tip-off that there's something wrong with this as a solution, and hopefully, you would go back and realize, like we did, that, oh, the arguments of logarithms have to be positive numbers, and that's why you would reject it as a solution. Okay, so we did it one way, and we got 2 as our solution. Now let's do it a different way and talk about how we would go about doing that in the second approach. So I'll put back what we lost here. Okay, second approach. So we'll just call this number 2 and start from there. How would I do this? Well, I'm going to take an approach here, like similar to what we did in part C. I'm going to exponentiate the whole equation, and I'm going to use 10 because that is the base here of the 2 logarithms that are involved. Okay, so on the left-hand side, I have 10 to the log base 10 of x, and plus log base 10 of x plus 3 equals 10 to the first. So that's just 10. Okay. And what do I do on the left? Well, think of this as 10 to the z plus w, right? This entire thing here is z, and this entire thing here is w. Where did I get those letters? I'm just pulling out random letters to show you something. If this were my equation, I could write it as 10 to the z times 10 to the w equals 10. That's what I wanted to show you, right? That's from the rules of exponents. So I'm going to use the same idea, right? The point is that I can now take each of these terms and put them as the exponent of their own base 10 logarithm. That's, again, from the rules of exponents, equals 10. Okay, and you can hopefully see what's going on here, very similar to what we talked about just a few minutes ago. 10 to the log base 10, they cancel out, and they just leave you with x. And I have a times here. 10 to the log base 10, cancel out, leave you with whatever's here. So x plus 3 equals 10. And we are now back to exactly the same place we had gotten to earlier using the other method. So from here, you get the same 2 solutions that we got, -2 and 5, -5 and 2. And then you have to reject this one for the same reason we talked about earlier. So again, x equals 2 is the only solution for this exercise, D. So zooming out a little bit here, just a very quick recap. This has been a video that has intended to show you that not only are these first 3 rules that we talked about in video 20.1 very useful, right? How to convert from an exponential to a log, how to convert from a log to an exponential, and then just a convention that comes up often. But in fact, if you look at number 1, right, like we said earlier, and you put this in for x up here, you get a new property, which is this one down here, which basically says that b log base b of anything is that something. So 3 log base 3 of something equals that something, 14 log base 14 of something equals that something. So 10, b and log base b cancel each other out. We didn't end up talking too much about this fact number 5 over here, but the similar thing happens if you start here, right? If you start here and you use the fact that c equals b to the x, and you replace the c here with b to the x, then you get this fact down here. So this is another way you could view it. So for example, log base 3 of 3 to the x equals x. Once again, taking the logarithm of the same base as exponentiating, right? Cancel each other out and leave you with whatever, in this case, the exponent was. So those are the two additional facts that are very useful when you are solving equations using exponentials and logarithms. And we talked a little bit about the rules of logarithms over on the right-hand side down here. There are some rules we didn't talk about in this video. There is a difference rule. So the logarithm of a quotient, like log base 2 of 7 over 3, turns into the logarithm of a difference, log base 2 of 7 minus log base 2 of 3. So that's this rule. And this one kind of sort of we just talked about, but it's a little different. So if log base 2 of 4 to the 17 is something that you want to simplify, you can actually take that 17 and bring it down to the front. So that would be 17 times log base 2 of 4. Okay, so that's what this is. You take the r and you bring it down as a multiplicative constant. Works the other way also, right? If you have 3 log base 10 of 4, then you can take this 3 upstairs, and that would be log base 10 of 4 to the third. Okay. All right, so then that does really go through all those 3 rules of logarithms. In the previous video, 20.1, we went through these 3 in detail, and then we just talked about these 2. So I think we've done it all. So I'll see you in the next video.